All right, y'all. So now we're going to discuss lesson A2, where we are exploring the transformations, where f of x plus k is inside the function. Yesterday they were outside the function. Today they're inside. So we are going to identify the effect on the graph of replacing f of x by f of x plus k. Yesterday we discussed f of x plus k outside the parentheses was up, and f of x minus k outside parentheses was down. Well, today I'm sure you can make the assumption that we're going to discuss left and right. Then we're going to identify the transformation used to produce one graph from another. Okay, so the function f of x equals the absolute value of x is graphed below. Okay, the absolute value function is written as f of x equals the absolute value of x, and as defined by f of x is the system of negative x if x is less than 0 and if x is greater than 0. Okay, I just read this math term here. So write a new function g of x by replacing x with x plus 7. So we are going to write the function. So f of x equals the absolute value of x, and ask us to write a new function g of x by replacing this x with x plus 7. Well, that's what this is. G of x equals the absolute value of x plus 7. Now graph both on the graphing calculator and sketch the graph. So this is where you need to go to Desmos, and you type in the absolute value that is on this little keypad here. You see this absolute value with A. If you type in that absolute value and you click X and you click it again to close it, you see the absolute value is graphed for you, the absolute value of X. Now if we graph the absolute value of X plus 7 and close our absolute value, you'll see that our function is translated to the left 7 units. It's translated to the left 7 units. From 0 to negative 7 is where our vertex transferred and translated to. Okay, so let's move on. And that's where you graph here. Make sure you graph that point here. Graph your absolute value with x plus 7. What is the x-intercept of the parent function? What is the x-intercept of f of x? Remember, this is the graph of f of x. This is the graph of g of x. So we're looking at the black line there, f of x. What is the x-intercept? Well, it intercepts the x-axis here at 0, 0. So the x-intercept of f of x is 0, 0. What is the x-intercept of g of x? Where does this graph touch across the x-axis? Well, it touches across is right there at negative 7. At negative 7, 0 is the x-intercept for g of x. Describe the transformation. Well, that transformation we just discussed was the graph of f of x is shifted, it's translated 7 units to the left. Note that the function g of x can be written as f of x plus 7. This means that x is replaced with x plus 7 in the function f of x. So, with knowing that, we know that f of x plus k, where you are adding something within the function, not outside of the function, you are going to go left. It's the opposite of what you usually think. Usually you think positive numbers are to the right. Well, there's a formula behind this on why it's f of x plus k. If you want to look that up, you can. But just know that f of x plus k, where k is inside the function, you go left. Okay? So looking back up here at our example, if we had f of x equals the absolute value of x, and then had g of x being the absolute value of x plus 7 outside of the function, I did not change my parent function at all. My parent function remained the same, and I added 7 outside. That would mean up. But in this case, we had g of x equal to the absolute value of x plus 7 inside my parent function. So that means left. That means left. Okay, so make sure you understand the difference between the two. Okay, so this is the third rule. This is the third rule of transformation. F of x plus k is left, where you're doing the transformation within the parent function. Okay, inside is what I try to get my kids to remember. I'm inside, not outside. The graph of f of x equals x cubed is shown below the black line. This is f of x is x cubed. This is f of x. Make a conjecture about the graph of x minus 3 cubed. Now remember, we still have our x, we still have our cubed, but we're inside of our function. And now it's minus 3. So if f of x, I'm going to rewrite it again here. If f of x plus k is left, then you should be able to assume now that f of x minus k is right. Okay, so our conjecture is going to be that the graph will be 3 units to the right. And if I graph this on my Desmos, go into Desmos, x cubed and x minus 3 cubed, we're going to have x cubed, and then we're going to have x minus 3. Whoop, I'm still on the same function line. X minus 3 cubed. You'll see my parent function is the red line there. The red line is my parent, and I'm shifted to the right 3 units. I go 1, 2, 3. I go from 0, 0 to 3, 0. So I'm shifting to the right 3 units, and that is what they graphed here. This blue line here is g of x. I'm shifting to the right 3 units. Okay, so revisit your original conjecture. If you made that conjecture, then you would say that you're correct. If you did not make that conjecture, then you would make the correction where needed. Okay, so how does the graph of k in the equation g of x equals f of x plus k change the graph? Remember, f of x plus k means that you go to the right. I'm sorry, to the left. Is shifted left k units. When k is positive, I was reading this sentence here when I said right. When k is positive, and right k units when k is negative. Okay. Now, yesterday we talked about the vertical translation. Today, these are horizontal translations. We're moving left to right, not up to down. We're going horizontal. A horizontal translation of a graph shifts the graph left or right like a vertical translation. A horizontal translation preserves the shape of the graph. The graph shape does not change at all. We're just shifting it. We're just moving it, kind of like textiles. You're moving them around. The tiles do not change. You're just shifting them around. Okay. Without using a graphing calculator, sketch the graph of f of x plus 8 equals 2x plus 8. You can use a graphing calculator here, okay? Just type it in Desmos and then copy over the graph yourself. But if you wanted to try to do this on your own without a graphing calculator, remember our parent function is 2x. Here we have 2 to the x power plus 8. We have plus 8 within the function, okay? It's not outside of the function, which means that we're going to go to the left 8 units. We're going to move to the left 2, 4, 6, 8 units. We're going to move to the left 8 units. Okay, now again, you can type that in Desmos and it will show you that 2 to the x power is my first function. So 2 to the x power. And then my second function is 2 to the x power plus 8. Oops, I need to go back up there. Plus. Well, it keeps shifting on me. Why is it shifting on me? Let's do this. X plus 8. Okay, Desmos requires you to type in a parentheses. Okay, so you'll see that from the parent function, the red line here, to the blue line here or purple line here, I'm shifting 2, 4, 6, 8 units to the left. Okay. All right, use a graphing calculator to check your graph. We just did. Okay, so 11 and 12 is check your understanding. I want you to pause the video and do that on your own. And then number 13 is a real world situation. Julio went to a theme park in July. He paid $15 to enter the park and $3 for each ride. Ooh, $30 each ride. That would be expensive. So he paid $15 to go, and then he paid $3 for every ride that he went on. He went on X rides. Write a function that describes the total cost of his trip to the theme park. Well, obviously, our variable is going to go with our $3 because he rode for X number of rides. So 3 times X is the cost of the rides, and then plus $15, the constant to enter the park. So f of X is 3X plus 15. Julio went back to the theme park in September. The entrance fee was the same, and each ride still cost $3. However, this time Julio went on 5 more rides. Use your function from part A to determine or to describe Julio's second trip. Well, Julio's second trip is going to be f of X plus 5. We're adding 5 to X. We're adding 5 to whatever number of rides that he rode when he went in July. Okay, so we're going to, inside our function, add 5 to X. Add 5 to the number of rides that he rode in July to figure out how many rides he rode in September. So 3 times X plus 5 plus 15. So if we're adding 5 inside of the function, what direction do you think our graph is going to move? How does the equation for Julio's second trip to the park change the graph of the first trip? If I'm adding inside, that means I'm going to move to the left. It moves the graph 5 units to the left. Now, you can check this by using Desmos, typing it in, and verifying. What kind of transformation describes the change from the first graph to the second graph? Again, this is a horizontal translation. If we're moving left and right, it's horizontal. If we're moving up and down, it's vertical. Julio went to the park again in October and went on 8 fewer rides than he did in July. So if we're going on 8 fewer, we're going to subtract. We're going to subtract 8 from the amount of rides that we did in July. If we subtract inside, that means that we're going to move 8 units to the right. Okay? If we're subtracting inside, it's to the right. Julio goes to the park again in November. Now it is the off season and the entrance fee is $10 less than it was in July. He goes on the same number of rides as he did in July. Write a function to describe Julio's fourth trip. Well, our 3X is going to remain the same because our rides are still $3. He rode the same number of rides, so 3X does not change. The only thing that changes is what's outside here. It was $15, and if it's $10 less, 15 minus 10 is 5. Okay, it's 5. So if we go from 3X plus 5, 3X plus 15, our initial was 3X plus 15. 3X plus 15, and we adjusted and modified the function to be 3X plus 5, what happens between these two functions? Well, the graph will shift down 10 units. It would shift down 10 units. Okay, you can verify that by also typing in both of these functions into Desmos and checking and looking at what happens between the two. Check your understanding 14-15, lesson 8-2 practice, and lesson 8-2 activity practice. At the end of the activity is your homework. Make sure you submit all your answers in the activity 8 assignments in Edulastic. If you have no questions, go ahead and submit it. If you do have questions, then hold off on submitting it until after our Google Meet on Friday. Okay?